Okay, wave function. The minute you see cos and sine together like this, right in the form, you should be thinking wave function. So express this in that form. Okay, so the first thing I would do is I would just write down that I've got k cos x plus alpha, and just over next to it, I'm going to write down. It's kind of, you're effectively saying that that's going to equal 5 cos x take away 2 sine x. That's effectively what we're doing, right? So I'm doing that because I need some space, first of all. But yeah, just definitely write that, and that's what we're saying. We're going to rewrite this in that form. So the first thing I want to do is use my expansion, which will be given at the front of your sheet, and yeah, which will be given at the front of your sheet. So I'm going to say that k cos, now x plus alpha, that's going to become k cos x cos alpha. And when it's cos, we change the sign in the middle, and then it's going to be sine x sine alpha, and don't forget your k there as well. Okay, so this first bit, it's just straight out of the beginning of your sheet. Okay. And then I'm going to rearrange it. I'm going to take my cos alpha and my sine alpha, and I'm just going to move them to the front. Okay, so I'm going to write k cos alpha, and then cos x, and then k sine alpha, and sine x. Okay, so all I've done is taken those. I've not switched the terms. Some people think that you're switching the x and the alpha. No, I'm moving this whole term to the front. In this case, it looks like that. I can see why people think that. But when you've got sine x and sine x and cos alpha, you're moving the whole term. So this whole term is moved to the front. I've done that so that I can now equate that with the question. So the question was 5 cos x take away 2 sine x. Okay. So if I said, let's say this is equal to that, okay, so this is still that, so that means that this bit is the same as this, so many prepositions, then that means that the 5, that has to be the same, doesn't it, as that, and this 2 has to be the same as that, because they're the same, those signs are the same, and this is the same. So that's the first bit, okay, do your expansion. And then I'm going to work out my k value. So at this point, I'm going to say, and you want to write this explicitly, okay, that's what the marking scheme says, that k sine alpha is 2 and k cos alpha is equal to 5. So make sure you write that down really clearly. And my k is equal to 2 squared plus 5 squared square root. It's basically Pythagoras, isn't it? So that's the square root of 25 and 4, so 29. So k is 20, root 29. Okay. So that's the first thing you want to do. Then you want to work out your alpha value. So alpha, right, tan of alpha is equal to, we know that it's sine alpha, sine over cos, isn't it? So I've got, let's write that again actually, so that's quite messy. So it's k sine alpha divided by k cos alpha, and the k's would cancel out, so sine alpha is 2, cos alpha is 5. So then if I do shift tan, and I'll take a new line for that actually, I'll then just say that alpha is equal to tan negative 1, 2 over 5. Yeah. So 2 over 5, tan of the answer. Well, actually, I've still got this in radians, so let me just check. Is this a radians question? Yep, we're in radians, so we'll just keep it in radians then. So 2 over 5, shift tan, inverse tan, I should say, 0.38 radians. And at this point as well, it's worth checking which quadrant you're in. So for me, sine and cos are positive. So where is sine positive? Sine's positive in here. Okay. Where is cos positive? Cos is positive here. And where is tan positive? Tan's positive here. So 3 ticks, so it's quadrant 1. So that's hunky-dory. If it wasn't, I'm looking for 3 ticks, and I'd use this to work out where I'm at. So that's me got k and alpha, and then I'll just stick down my answer. So if I rewrite that original form, I now know what k and alpha is. And it was a plus, wasn't it? So root 29 cos of x plus 0.38 0.38. That's your wave function, and that's you got 4 very nice little marks. So the next bit, this is the context. Now this is using it. It says that the diagram shows part of this sketch. Okay, now please note how similar that is. So this is what we've rewritten. We wrote that into our wave function, and now it's talking about this diagram here. Okay, now just note how similar that is to this. Yeah, this bit here is the same as this bit. So all they've done is we've added on 10 to our wave function, haven't we? So it's saying it's showing that diagram and y is 12 and find the x coordinate of p and q. So it's asking, well, where does this line, when is that equal to 12? It's pretty much what it's asking, isn't it? So let's write that out then. I'll see if I can remember this. Part B. I've already forgotten it. I got y and then forgot. 10 plus 5 cos x. And I think it was take away 2 sin x, yeah. Memory is not very good, 2 sin x. So it was asking, well, when does that intersect with the line 12? So you'd say, okay, well, the line is 12. So there we go, 5 cos x, take away 2 sin x, nice. And then you're thinking, well, that's quite a hard solve, isn't it? Well, not really, because we have already worked out, and I'll just put the 10 there, we've worked out that this is the same as our wave function. So that's the same as root 29 cos x plus 0.3. And they always get you to do this, to use your wave function, at the end. So we're just going to do a rearrange then, so take away 10 from both sides and divide by root 29. So 2 over root 29 is cos x plus 0.3. Now sometimes they talk about max and min and things. Don't forget the max of this would be this number plus 10. The min would be negative this number plus 10. Okay? Sometimes you just ask, when is it the max? So if this wasn't here, the 10, you would just say, well, put this function equal to root 29. That's when you're going to find the max. That comes up a wee bit as well. So now I will do inverse cos 2 over root 29 x plus 0.38. So 2 over root 29, and then inverse cos, shift cos. So that's going to give me 1.1, well 1.2 actually, we'll do 1.19 is equal to x plus 0.38. And then we need to do our cast diagram, so I'm looking for when was this positive. Yeah, it was a positive number we had up here. So when is cos positive? It was positive in quadrant 1 and quadrant 4. And in radians, this would be 2 pi take away x, wouldn't it? In the same way, that would be pi take away x and pi plus x. Okay. So quadrant 1 and quadrant 4. So I've got 1.19 is equal to x plus 0.38. So we'll just do 1.19 take away 0.38. So that's 0.81. That's my first answer. And my second answer, I'm saying I've got 2 pi take away 1.19, and that's equal to x plus 0.38. So 2 times pi, take away 1.19, take away 0.38. So x is equal to 4.7. Oops, lost my pen. 4.7. And that is 8 marks. Isn't that fantastic? So I'll have to zoom in because my other questions are going to pop up on the side there. So again, this is a very similar pattern. Definitely these first 4 marks should be within grasp. Do your expansion. This is effectively a Pythagoras. Sine over cos to get your alpha. Write down the answer. There's not a lot to remember there, really. 4 marks. This one, just be careful. They twist and turn it a little bit. The thing that I think is quite hard is if they ask for the max and min, and usually this is the max and the min, isn't it? Because if you've got 2 cos x or 2 sin x, the max is 2. So here the max would have been root 29 plus 10, the min would be negative root 29 plus 10. So sometimes they ask for that, but really it's just basic trig we've been working on. So I hope that's helpful and definitely worth studying.